Welcome back. This time we're going to move in this video into our look at problems from Unit 8, Annuities and Sinking Funds. So we'll lead it off with problem number 5. I think the important thing on this one is to realize, well, twofold, whether it's an ordinary annuity or whether it's an annuity due. And in this case, I think you basically are going to see the word annuity due when that's the play. Secondly, to decide whether we're going to be asked to find a present value or a future value, at some point in time. So you read problem number 5, and you got Tim Teflon, and he wants to create an annuity that will enable him to withdraw $20,000 for 8 years, and the interest rate is given at 10% annually. So in this case, you're finding the present value. How much does he need to put in so that will set up that situation that will enable him to withdraw $20,000 a year for 8 years at an interest rate on that investment at 10% annual. So it's a pretty cumbersome looking formula. I've written it for us. PMT references the payment amount, and he's going to want $20,000 each of those payments. So that's my value for PMT. The interest charge is per month. Okay, so I'm sorry, per year. This is a yearly situation. So he's going to withdraw $20,000 at one point at the end of each year. So the reference time is a year, not a month. So that I stand corrected. So we're going to use 0.10 as the value for I, and N references the 8 years. So you can see a straight plug in at 0.10 for I. Again, if I were to calculate this thing, I think you're best served by figuring out what 1.10 to the 8th is, taking that value and having it divide into 1, taking that value and subtracting it from 1, and then taking that value and dividing by 0.10 before you multiply by $20,000. You can do it in one big punch, and just practice with your parenthesis if you're going to do that. The rest of the arithmetic works fairly well with a calculator. I wouldn't want to do it without one. And we will find out at the end of all those calculator punches that he has to deposit $106,698.52, and that would facilitate being able to pull back $20,000 per year over a span of 8 years if you weren't able to get a 10% annual interest rate. So problem 5 sets up. Your final answer is go ahead, deposit right now $106,698.52. Problem 6. All right, so first of all, on problem 6, we've got $2,000 semi-annually to Best Bank. It's going to pay 4% compounded semi-annually. After 5 years, he's going to make no more deposits. The question says, what would be the balance in that account 10 years from then? So the first thing we're going to do is we're going to figure out the future value of that annuity. All right, so we're going to set up to a place where we're going to say, all right, we're going to put $2,000 in every so twice a year. So in terms of content here, your period is a half a year. So the compounding interest rate every half year is 2%, 0.04 cut by 2. The number of compounding periods, N, is the 5 years times 2 per year, or 10. Different formula this time. We're calculating future value. How much would that annuity amount to at the end of those 5 years? All right, the payment value, 2,000, 1.02, and in this problem is played by 10. It's a different formula. Follow through, calculating 1.02 to the 10th, take away 1, subtract that value by divide that value by 0.02, take that end result and multiply it by 2,000, and you find that the annuity at the end of those 5 years is now worth $21,899.40. That's cool. But what he's going to do then is he's going to let that money sit, and it's going to compound. And the question we're going to have is, how much will he have after he lets the money sit for 10 years? All right, so that $21,899.44 should look familiar because it's the value that the annuity grew into at the end of that first 5-year window. Now he's just going to let that sit. So this is not an annuity. This is a one-shot investment where your principal is the $21,899.44. That's your present value. Same interest rate. So it's 4% cut by 2. And then the number of compounding periods is actually 20, 2 times 10 years. He's going to let this money sit for 10 years. And the question for us is, how much will it be worth at the end of that 10-year period? Be careful, this is not an annuity. This is a single investment where we're calculating future value on a present value of $21,899.44. It's kind of what we did in Unit 6. So I'll let you punch some calculator buttons, and you find that that annuity would grow into a value of $32,541.42 at the end of that 10-year window, and problem 6 is finished. I like problem 7 a lot. Maybe it's because I'm close to retirement age, but it speaks to me. All right. So the problem basically says he wants to invest a certain sum of money now and then have that money grow into a certain value so that he'll be able to pull back $30,000 every year for 25 years. Okay. So you'll notice on the little picture, I put 2 question marks. As it turns out, the first thing we need to do is find the present value of that annuity. Right? In other words, if we look down the timeline, 15 years, how much does that money have to be worth? So we're going to go ahead and find the present value of that annuity that is $30,000 a year, 25 years at 0.09. So looking at what we've got, the payment amount for determining present value, $30,000. 0.09 is your value for I, and the value for N is the 25 years. So what we're going to wind up having to do is calculate what you see on your screen right now. Again, for my purposes, I think you're better served at 1.09 to the 25th first. 1 divided by that value subtracted from 1, that result divided by 0.09, and then go ahead and multiply that by 30,000. From my perspective, there's not a need to show me the 9.8225. I just use full screen display on your calculator. Don't round it. And what you realize is for him to have that chunk of cash that will enable him to pull out $30,000 a year for a span of 25 years, his annuity would have to have a present value of $294,677.39. So that's the amount of money he's going to need when he sets up his retirement in 15 years. Okay? So we're going to go down and finish our problem by trying to find out how much he has to basically invest right now. So your unknown here is a present value for a one-term investment. He's going to walk and say, here's some cash, and knowing that at the end of 15 years, it will have grown to be the number that drives that annuity value, to be the $294,677.36. So it's a straight run as we did in Unit 6. 1.09, 15 is the number of years that's going to sit. We're going to solve for P by dividing the 294,667 by 0.36 by 1.09 to the 15th. It's you, me, and your calculator, and some good arithmetic tells us that he should walk in and start that investment with $80,900.15. And that would be his initial investment that would grow into a sum of $294,677.36 at the end of a 15-year window, facilitating his annuity that would enable him to withdraw the requested amount every year for 25 years. It's a good problem. Attack it in 2 stages. Stage 1 was find the present value of the annuity. Stage 2 was find the present value of a single one-shot investment that will generate a future value that turns out to be what the present value of that annuity was. So it's a cool problem. I like it a lot. It's number 7. Here comes number 8. Number 8's a pretty clean problem. It just asks for amount for a sinking fund payment. Formula you can reference from notes. You've got the future value of an ordinary annuity times the interest rate, all over 1 plus the interest rate raised to an nth power and a -1. And this time the future value, they want to raise a chunk of $100,000. The question basically says how much do they need to invest over a span of 10 years. In this case, we're compounded at 8% quarterly. So you're going to enter some values that $100,000 is the future value. That's the amount they need to generate. 0.02 is the interest rate for every quarter. All right. On the bottom, you're going to see 1.02 and the number of compounding periods over a 10-year window. If you're compounding quarterly, would be 4 times 10 or 40. And the rest of this problem is pretty straightforward in terms of calculator run. Just be careful on the denominator. If you're doing it in one shot, group that entire denominator. Otherwise, it will do a divide by 1.02 to the 40th. And from that, try to subtract 1. You do not want that. You want to make certain that you group your denominator and Bottom line is that each payment would be $1,655.57, and that will set up their sinking fund so that it will have a value of $100,000 when they need it. That is problem 8. Let's go to 9. The problem specifically says this is annuity due, and we're finding a future value for this annuity due. The payment amount is $800, 6% compounded quarterly. By now, we're getting used to this calculation for I and N, 0.06 cut by 4 because of quarter compounding, 0.05 each quarter. And the number of compounding periods over an 8-year span would be 8 times 4, or 32. A more cumbersome formula, again, you're not required to memorize these formulas. You have access to them. Feel free to pull them up and use them. Your straight plugins, 800 for payment, 0.015 for I. I've taken the liberty of already adding it to 1. And you and your calculator. Again, my advantage here, I think, is to do the middle parenthesis set first. Raise 1.105 to the 32nd, subtract 1, divide that by 0.015, hit equals, and then simply a couple of multiplies by 800 and by 1.015, and you find that the future value for this annuity is $33,038.89. If number 10 looks familiar, it probably should, because it's very similar to what we did a moment ago, where you've got a situation where at some point in time, you've got somebody who wants to retire. This person's going to work for 8 years and then retire and wants $50,000 every year for 20 years and is able to get an interest rate of 5%. So here's what we're going to do. We're going to calculate present value for that annuity just as we did before. So it's the same formula. The value is being plugged in. Payment amount, 50 grand. Interest rate at 0.05. And the number of compounding periods is the 20 years, since we're compounding once a year or annually. So I won't belabor the calculations. We've kind of already talked about how I think is best. So what you find out is the answer to the present value of that annuity, or the amount you'd have to have generated at the end of that 8 years wherein you attempted to want to retire, is a pretty hefty number. It's $623,110.52. And as you already know, there's a second part to this problem, wherein we will take that number, that 623,000 kind of number, and it becomes the value in the future, or the future value for a single shot investment, wherein you and I will calculate for P the present value of that investment opportunity. Same interest rates, 0.05. So we need that money at the end of 8 years. So N is 8. Once again, it's you and me in a calculator. It's 623,110.52 being divided by 1.05 to the 8th. And we find out that we will set that opportunity up for a present value of $421,745.73. And that, my friends, wraps our problem set from unit number 8. I'll be back soon with problems from unit 9. See you then.